All right, this is my favorite topic in mathematics that I get to teach anyway. It's trying to put together a function rule based on an input-output table, and we're going to see some of these as visual patterns as well. The goal here is, of course, to get something in the form, hopefully y equals mx plus b, if it is linear. Hopefully it's slope-intercept form if it is linear. So let's first look at if it is, in fact, linear. I'm going to always go to the equation change in y over change in x. That describes slope. You'll notice that the change in y here is different every single time, and that's okay. That can still mean that this is linear. You can have a variety of different, it could be changing by 100 and then a billion. It doesn't make a difference as long as the ratio between y and x is the same throughout. So change in y, I'm going to pick these 2 points right here because it's such a small amount that I can do a limited amount of math. So your change in y right there is -1. Your change in x right here is also -1. So it's a change in y over change in x, so it's -1 over -1. That slope is 1. And if you look at any of these, I think that's also true. Right here it's going down by 12, and right here it's going down by, or it's going up by 3. Huh. Maybe this isn't a linear function. What do you know? So you always got to be on the lookout for that. Here's another example for us. Again, I'm going to start with change in y over change in x. So change in y over change in x. I can tell it's a function right away. I have different input values throughout here. And again, I'm going to go to normal numbers here, positive numbers, the things that we're used to. I could have started with these negatives, but I feel more confident with these. From 4 to 8, the change in y is 4. From 7 to 9, the change in x is 2. So therefore, your slope here, 4 over 2, is 2. And if I look at this one right here, your change in y, it looks like y goes down by 8. And right here, your your x goes down by 4. And -8 over -4 also reduces to 2. So the slope is the same. And let's do one more to be safe. This goes down by 14. This goes down by 7. Again, -14, let's do it right here. -14 over -7, that's going to reduce to 2. Everything is 2. So I can tell you that the slope, we always want to start with y equals mx plus b, and the slope is going to be 2. To find the b, the y-intercept, you could do 2 things. Number one, you can intuitively understand that wherever x is 0 is your y-intercept, so I can tell right away that the y-intercept would be -10. Or just take any 2 points. So if I go from 9 to 18, 9 times 2 is 18, and then I take off 10, I get 8 right there. So that would work for that one as well. Here's a visual pattern. You can see it's going from 6 to 12 to 18 to 24. If I count these out, 1, 2, 3, 4, 5, 6. So, and then there's also an addition of 1. So I can tell you right away that the pattern here is to add 1 because we have that extra. And each time it goes up by 6 blocks. Hopefully you see that. So you're going to take whatever step number you have and multiply by 6, add 1, and you'll end up getting the total number of blocks. If you don't see it in terms of a visual pattern, I always like to pull the information into a chart. So if I look at step 1, there's 7 blocks. Step 2, there's 13 blocks. Step 3, there's 19 blocks. And the change in y here is 6, it's increasing by 6. And that is a consistent pattern. If you look at each x, we're only changing the step value by 1. So the slope here, change in y is 6 over change in x is 1. So your slope must have been 6, and that's where I derive that number right over here from. And of course, the plus 1, if I look at getting from 1 to 7, I don't just multiply by 6, I have to add 1. I don't just multiply 2 by 6 to get 13. I multiply 2 by 6 and get 12 and then add 1. So that's why your visual pattern here will say y equals 6x plus 1. If you wanted to start back at step 0, let's say we were trying to find, hey, what's going to happen when x equals 0? Just plug in this equation. If you do 6 times 0, you get 0, add 1, and you actually would have 1 block back in step 0. A couple more things to show you just real quick. What would be the equation for this function right here? It just looks like that every single time my input, my x value is 4. So you could just simply say x equals 4. And that's pretty evident in the graph as well. It doesn't matter what the y value is. X is just consistently 4 throughout there. And you can see that over here with the outputs. This, though, I want to point out to you, is not a function. So if you look at the x values here, they're constant. They're always 4. They don't change, which means if you go back to that formula for slope, change in y over change in x, the change in x here isn't happening. So you're dividing by 0, and hopefully you remember from class, if you divide something by 0, the calculator will actually say on it error or something to that effect, which indicates that it's an undefined value, and that's what you have right here. Anytime there is a vertical line, it's really an undefined slope. And this one right here, you can see my outputs are always 1. I kind of gave up writing the inputs here. I just got tired. But the graph would look like this. It's just a straight line going across here. So the function would actually just say y equals 1 because the outputs are always 1, and that's what the graph indicates. This is a function because each input has exactly one output. And horizontal lines are considered functions. If we go to that formula for slope again, the change in y isn't happening here. But x is changing, whether you want to say it's going down by 3 or it's going up by 3 or what have you. X does have a value that isn't 0 right here. And so you can do this on a calculator. If you typed in 0 divided by 7, just as an example, that would come out as 0.